A failure that improved your deployment playbook.
Gosh, there's so many. I don't know if I could name one, but I look, most of the failures start in the beginning, which is in the fact that the factory is dynamic, right? It changes all the time. The mix changes, tools go up, tools go down. So models will always drift. The modern fab is very, very complex. It's really too complex and dynamic for humans to be able to optimize based on a simple heuristic model or based on intuition. Traditional static optimization algorithms fail at because of the scale and because of the frequent changes in the factory. If you just are operating on statistics alone, you're just going to consider that average and the standard deviation, and that's about it. And you'll have an error because of that. They're not going to allow us to come in and mess with their data willy-nilly. It's a dark art. That operator is the only person who knows how to tweak these knobs. They do this and that, and we don't exactly understand what they do. We are constantly monitoring the model against a baseline that's always being spun up in the background.
What's your playbook for dealing with this type of data, where there's missing data, noisy sensors, tool-to-tool variation, and model drift over time?
They treat their factory data as the crown jewels of the company, right? They are very reluctant to give up any control over that. You don't always know exactly why a certain path was chosen, but you could simulate different what-if scenarios and you can say, okay, did this actually happen in real life? Because a lot of this is not about technology, it's about human politics sometimes plays in bringing these sort of things in there. And I have to, this 5% improvement, and then 10 people are claiming that same 5%. They'll try to show that the other methods are not working and only their method is working, right? Implementation and acceptance of AI is half of it's the technology, half of it is the human organizational factor that is sometimes the real barrier for implementation.
Today, we speak with Itzik Gilboa, CEO of minds.ai, a distinguished leader at the forefront of smart manufacturing with AI.
Highly respected in the sector, Itzik brings extensive expertise in utilizing the Maestro platform to deliver tangible performance enhancements in large-scale semiconductor fabrication. His leadership highlights minds.ai's significant influence in partnering with major players like global foundries to deploy AI-driven solutions across their global facilities.
Prepare for an insightful discussion on navigating the challenges of AI adoption in the fab and the critical advancements driving operational KPIs, including on-time delivery and throughput. Beyond the status quo, let's dive in.
Hello and welcome back to the Semiconductor Leadership Podcast. I'm your host, Salah Nasri. And yes, whether you are a semiconductor veteran or someone who's just curious about semiconductor manufacturing, this is your podcast. Before I start, look, it's been a short spill doing this podcast. We've hit more than 200,000 views across all platforms on YouTube, Spotify, and Apple Podcasts. But when I look at the back end, only 3% are subscribed to the platform. So do me that favor. Click that subscribe button, and I will promise you that I will make sure to work hard and bring special people from the industry who are powering the manufacturing ecosystem, which is the semiconductor world, on a day-to-day basis. So, ladies and gentlemen, without further ado, today I have Itzik Gilboa, CEO of minds.ai. Itzik, welcome to the show.
Thank you, Salah, for having me.
It's a pleasure to have you, Salah Nasri. Actually, someone said to me the other day, was like, Salah, you should come up with a nickname. So it's either going to be like Semicon Salah or the Semiconductor Maestro. I'm still trying to think about it. But yeah, no, hey, welcome to the show. And yeah, I mean, Itzik, first of all, I think it's vital that the audience out there know who you are and know what Minds AI is about. So I'm going to start off the podcast with some rapid fire questions.
All right.
In one line, what problem does Minds AI solve best for fabs?
We solve an issue of multiple optimization across the whole factory between throughput, cycle time, and utilization. Typically, those KPIs don't necessarily work in concert with each other. You have to give up some of one to gain on the other. We are enabling factories to achieve optimization across multiple KPIs simultaneously across multiple areas of the factory. By that, we get more output, better cycle time, better utilization, and to the tune of hundreds of millions of dollars of value per factory per year.
Faster ROI today, yield lift, cycle time cut, or energy reduction?
I think yield lift is always going to be the biggest one. Cycle time is a matter of the industry cycle. You know, if the industry is in an upturn, then faster time to market and better turnaround on customer requirements is very beneficial. Customers will pay a premium for that, but they won't do that in a downturn, right? So it's kind of cyclical. Energy is always there, but it doesn't yield the same level of returns as yield does.
Fair. First 3 checks before you trust a new data set.
We look for a few things. We look for congruency, meaning are the labels the same across multiple sources of information, holes in the data, corrupt data. Those are the 3 things that we look at.
Overhyped in Fab AI, end-to-end autonomy, or underhyped good context models?
Overhyped. Say that again.
So overhyped in Fab AI, end-to-end autonomy, or underhyped good context models?
I would say underhyped good context models.
Okay. Your go or no-go rule for moving from POC to production?
We need to show results.
Fair. DeepSim, in a word, what's the superpower?
A fundamental training platform that is unique to semiconductors.
Maestro's most loved feature by engineers. What is it?
The fact that you don't have to rip and replace anything in your factory.
Love it. Human in the loop. One behavior that makes models dramatically better.
Human in the loop. One human behavior that makes models better. I would say the ability to accept the model.
That's the convincing section, eh? Favorite early win you target in the first 60 days?
Favorite early win is typically when we deploy on a small set of tools and we can show that we've significantly increased utilization on that subset.
One KPI every customer should track from day one.
Overall output, I would say.
The KPI leaders neglect but shouldn't.
I think one thing that they don't think hard enough is about how to normalize these KPIs with some dynamic denominator, like moves over WIP or over another measurement that would give them a sense of how the dynamics of the factory change the KPIs.
Working. Common root cause of model drift and your quick fix.
So common issues for model drift are the fact that the factory is dynamic, right? It changes all the time. The mix changes, tools go up, tools go down. So models will always drift. We have built a MLOps pipeline that constantly monitors for that drift and is always training a model in the background to replace the one once it drifts off by an amount that we decide together with the customer is the trigger amount.
What makes a great operator facing AI recommendation in 5 words or less?
5 words. A great operator. Somebody that is willing to accept change.
Yeah. Security must have, you refuse to compromise.
We don't compromise on exposing customer data. That's the one thing that we never compromise on.
If you were to get 10% extra budget this quarter, where does it go?
Improving our simulation capability.
Best partnership to accelerate outcomes. Equipment vendor, EDA, or cloud?
We got tremendous help from cloud providers because they're very well deployed across every single customer that we have. They know all of the buyers. They know the decision hierarchy. So we've been getting a lot of traction from that.
What turns a cool demo into a trusted control input?
Again, it's the results, right?
Yeah.
We have to see, that the results are there, the KPIs are met. We're really conservative with how much we assess the impact, and we typically exceed what you
guys do. One dashboard tile you keep on every screen.
Ooh. Again, we look at model accuracy. That's what we look at. How accurate is the model compared to what the reality is? You have a prediction versus reality. That's what we look at.
A failure that improved your deployment playbook.
Gosh, there's so many. I don't know if I could name one, but look, most of the failures start in the beginning, which is in the data ingestion. We learn a lot from assimilating customers' data, looking at their data hygiene, and we're constantly improving our workflow to accommodate for that. So we're getting a lot better in terms of how quickly we can deploy because we've learned that.
Marvelous. Time to value target for a greenfield fab, your realistic number.
Yeah, it's going to be dependent on the type of application we deploy. So if we're deploying a tool model that is talking about improving utilization in a specific tool or tool group, days to train the model, week to 2 to get results very quick. If we're talking about a fab model that predicts outcomes on a factory level, that takes weeks to train, months to deploy and validate. And if we're talking about a scheduler that actually does control, which is actively takes action, that's probably 6 months to full deployment.
This one's going to be an interesting one. Most overrated buzzword in industrial AI.
I think the term lights out fab or smart factory gets overused, and everybody has a different definition for those terms. We use it as well. I mean, we are trying to be part of that smart factory, but it's a bit overused.
And the underrated one.
I think that a word that's underrated. I can't come up with an
Underrated one?
where
And the last one. Finish the sentence. Great fab AI is.
Great fab AI is one that you don't notice is there.
Wow. Because they got to find it out for you. Fair play. There you go. Thank you for doing the rapid fire question. It was mind-boggling at one point and thought-provoking. Itzik, let's go and talk and get direct into your career journey. So, what milestones led you to Minds.ai and focus on AI-driven optimization for the semiconductor industry?
Sure. Let me talk a little bit about myself, but
Sure.
I'm not the founder, so I'll make that clear. I'll say, I know the founding story, so I'll tell you that as well.
Sure.
But if we talk about me personally, I grew up in the semiconductor industry. I was a process engineer. That's how I started. I'm a material scientist by trade. I developed process technologies for making the chips. I've then ran integration teams and R&D teams that developed processes. And then I moved into operations, running factories as third-party suppliers to our company. I was involved in transferring technologies from one company to the other. I ran a joint venture between two large companies, which was the biggest foreign investment entity in Japan. It might still be the joint venture between SanDisk and then Toshiba, now Kioxia. And then I ran a product group, and I grew a product group to close to a Fortune 1000 size business from inception. So I have, an end-to-end understanding of the value chain in the semiconductor environment. I am very intimately involved with the pain points of running a factory. Because I was also entrusted with predicting supply and dealing with supply-demand mismatches. I went through probably 10 to 15 cycles of upturns and downturns in the semiconductor industry. And when I stumbled upon this company, I thought, wow, this company is doing something different. This company has a level of expertise that I haven't seen around, and there's much more than fluff here. And they're solving a problem that I intimately was involved in dealing with. So it was exciting. I felt like coming on board this company was a culmination of the sum total of all of my experiences so far, and it's a wonderful place to be. So that's my personal story and when I came to Minds.ai. But if we talk about the founding of the company, Sumit Sanyal and Timon Thielman, those are the two co-founders. The story of how they came into AI was Sumit was a design engineer working on dealing with noise cancellation. And noise cancellation algorithms. He came across an article that was coming out of the University of Toronto in 2013 titled Speech Recognition with Deep Recurrent Neural Networks. It was authored by Jeffrey Hinton, Alex Graves, and Abdel Rahman Muhammad. Those four guys authored this paper. And now Jeffrey Hinton is well known for, getting the Nobel Prize.
Right.
For, I think it was for physics, but it's really computer science. He read that article and he was floored because he realized that everything that they were doing in the company could be massively improved if they use these techniques of neural networks and deep learning. Went to his boss, said, "We got to ditch everything that we've been doing so far. Just throw it out the window and let's go with this approach." And his bosses didn't want to listen, didn't want to accept that. And he said, all right, I'm just going to go do it on my own. And he founded Minds.ai. And he was looking for some of Geoffrey Hinton's students. He found Timon, who was one of the original cohorts. His classmates went to found OpenAI.
Wow.
So that's how the company started. Initially, they were going to do hardware for AI, and then they decided to pivot to software. So that's the origins.
Marvelous. So, I mean, here, based on the team's research here, you said fabs can't innovate at the pace humans alone can sustain. What specifically do you believe AI segments best do on the fab floor?
So the modern fab is very, very complex. It's really too complex and dynamic for humans to be able to optimize based on a simple heuristic model or based on intuition. So the greatest strength of AI is augmenting human expertise in a way that can learn from the best of them, but also deal with any situation that comes up involving, multidimensional optimization. When you think about the dimensionality of the problems that you need to solve in a semiconductor factory, it's hundreds of thousands of dimensions, right? And trying to optimize across all of them is impossible in human capacity. So if you can't really compute all those variables or optimize across all of those spaces, a neural network optimization type of algorithm is much better suited to do that.
Right. And in kind of one or two sentences, we mentioned it briefly in the rapid fire questions. What problems do you uniquely solve for large scale semiconductor manufacturers?
So simply put, again, I'll sort of elaborate on what I said before, but we do dynamic optimization of the whole factory with conflicting KPIs simultaneously in a stochastic environment that's changing all the time. So that's a challenge that traditional static optimization algorithms fail at because of the scale and because of the frequent changes in the factory. So just imagine that you assume that a certain process is going to take a certain amount of time, right? You statistically measured it, right? You have a standard deviation and you've got an average and you say, okay, there's this bell curve and it's going to fall anywhere in between these things. But there's a reason why you're on a certain part of the bell curve. It could be that the previous operation took a certain amount of time. It could be that there's another machine out there that is not working properly, right? If you just are operating on statistics alone, you're just going to consider that average and the standard deviation, and that's about it. And you'll have an error because of that. A dynamic model considers all of those variables and will calculate a different outcome each time that environment changes. So that ability to adapt to a dynamic environment is unique to the way a neural network works.
Intriguing. So I want to move in more into the actual technology itself. I think it'd be important for the audience, the viewers who are watching as well, is to understand what DeepSim is in plain English. So if you could share us, what is DeepSim? And yeah, I mean, that'll be the first question. That'll be that, and then I'll give you a follow-up on that.
DeepSim, very simply put, is a neural network training platform. That's what it is. It's the culmination of a decade of experience in neural network training and reinforcement learning, and it's the basic platform that we use for Maestro, which is the semiconductor purpose-built training network.
I see. And how does it combine open source and proprietary AI into a stable cloud platform for the semiconductor industry?
So we use open source to build some of the training platforms. That's most people do that. Where the proprietary part comes in is adopting that to semiconductor manufacturing, using semiconductor manufacturing expertise, which we have in-house, and adopting unique workflows that we have as a result of the experience that help us deploy, link up to existing manufacturing control systems. So we had to learn how to bolt on our solutions onto a bunch of myriad different solutions that are out there so that it could seamlessly integrate.
And so what does Maestro add? I mean, from a UX point of view or workflow concentration or from a governance point of view, that makes it really usable for the production team?
So Maestro is the semiconductor-specific workflow. The algorithms for forecasting, scheduling, planning, control, in particular, tool forecasting, tool optimization, hybrid fab simulation, which means using simulation and historical data to create a prediction of what the factory is going to do, and reinforcement learning scheduling, which is using a reinforcement learning agent that can actually schedule, can actually take control of the scheduler, not only predict, but actually take action. That's what Maestro is. It's the specific semiconductor implementation of DeepSim.
Intriguing. And from your perspective, which AI approaches, be it in deep learning, reinforcement learning, or hybrid physics with ML, casual, show the biggest wins in fab processes?
So the simple answer is all of the above.
Okay.
We use all three. We use supervised, unsupervised, reinforcement learning. Another part of our strength is to know exactly what combination and which one of those to use in different contexts.
Okay.
Right? We don't always need to use reinforcement learning. It's a pretty heavy duty training requirement. We don't need to use it in certain cases. We won't use it, right? So we're agnostic to the methodology. We care about the result.
Could you walk us through the life cycle, Itzik, from data assessment to POC to the validation to site-wide rollout? Where do most projects get stuck?
I'd say most projects get stuck in the beginning, which is, so first of all, you correctly identified the cycle, which is, first you do the data assessment, the data cleaning, and then you do a point of a POC, which, depending on the customer, can take days or weeks or sometimes even more, how complex the problem is. Then you go into validation. Like you say, you want to make sure that the solution that got deployed is actually yielding the results that you want. And then you deploy it across the factory or across a number of factories. But what we've seen is, specifically on the data side, is poor data hygiene. Give you examples of poor data hygiene. It's you have data labels that are inconsistent. One piece of data is called a certain label on one side of the factory. The same piece of data, when it transfers to another area of the factory, gets relabeled to something else. Now you have incongruent data, corrupted data, or simply it doesn't get saved at the frequency that needs to get saved in order for you to properly train an AI model, right?
But you mentioned at the beginning, is like I think the challenging part is the data assessment part to the POC. Is that basically based on, if I recall from the rapid fire question, it's where is convincing them at the beginning, convincing them the value of using a system that minds.ai is providing?
So we try to come up with relatively straightforward demonstrations of the value, right? You could start with synthetic data, right? And say, hey, here's a synthetic data set. Here's what our model can do with that. That typically can get you through the door, but it's not enough. A customer wants to know that it works on his data, that it works on his factory. So you can get away with you have corrupted data or you have incongruent data, but you can assimilate enough of it to create enough of a demonstration. So that's what we do. So we try to work in parallel, right?
Right. So which use cases deliver the fastest ROI, would you say? Was it either equipment set optimization, recipe tuning, SPC alarm reduction, scheduling or dispatch, or yield improvement?
So the fastest ROIs are the ones that take the shortest amount of time, and that's typically an impact that you could show on a tool level, an individual tool level, a group of tools where you can improve the utilization of the tool, right?
Right.
So if you say, I want to be able to get more output out of this group of tools, you can deploy our tool model and you can show that result within days to weeks. Trying to show an impact on a factory level takes a longer time because you have to consider the cycle of the factory. Typically, a modern semiconductor technology would take between 6 months to 9 months from start to finish. When you start a wafer and you go through all the thousands of steps that it takes until you get to the finished good. A typical customer, if he wants to show an output, an outcome, he want to see it on the order of magnitude of that time frame, right?
Right.
So that just by that, it takes a while, right?
Could you share it? Could you share like a non-confidential example with potential like numbers?
So we've published information that's based on work with our customers that showed on a factory level anywhere between 1% to 3% of output improvement. And when you think about it, think about a factory that's worth $30 billion of capital, and you take 1% of that, that's the $300 million a year, right?
All right.
So small percentage points of improvement get you huge amounts of value because of the amount of capital that's deployed. And by the way, that's one of the reasons why I think one of the questions you asked, why did you go from pharma and energy into semiconductor? That's one of the reasons we did it, is we realized that there's just so much value in it, and it's relatively straightforward to be able to extract that value.
So with that methodology, or let's say with that mindset or the unique selling point, surely all these fabs around the world should be adopting the Minds AI system. What could be the reason that holds them back? Or
there's several reasons. One is they need a certain level of expertise in order to be able to adopt our solution, right? People need to be able to deal with their internal data infrastructure. We don't do that for them, right? That's one. There's a certain level of trust that we need to establish. We're actually holding the crown jewel of that said enterprise, right? And they're not gonna allow us to come in and mess with their data willy-nilly. So that's another. And some of them have been trying to do it internally for quite a while. Some of our customers, by the time we come in, have hired hundreds of AI ML people, and they've been at it for years. And they come in because they bring us in because they haven't been successful. So it takes a while to do it. I think there's also a flywheel effect. It took us a while to get into the semiconductor industry. We've only been in semiconductors for 3.5 out of that 10-year period, right? And it took us a while to develop the semiconductor specific applications, get it to work, deploy it at scale, and we're now in 7 fabs and counting. But I feel like at some point we're getting to that inflection point where we can adopt faster and get more customers.
Marvelous. I mean, referring to the people, the process engineers, how do you keep process engineers and operators central to the loop so models, remain interpretable and actionable as well?
There's a lot of interactive discussions that we have with these engineers and training so that they understand the process. We provide detailed dashboards that give them insights into what the agents are doing. We enable the process engineers to be comfortable with what the agents are doing so that they can work together with the AI agents and not necessarily, this isn't a competition, right? So in most cases, we're dealing with a situation where human capital is extremely valuable and rare, right? We don't have enough expertise in these places. So they're all too happy to have a tool that would enable them to relieve some of that pressure. Right. You can't imagine how many times I come into a conversation and they tell me, so-and-so is retiring and we don't know what to do because that operator is the only person who knows how to tweak these knobs. And it's a dark art. They do this and that, and we don't exactly understand what they do. So we come in and we provide that ability to augment that human expertise and do it in a consistent way.
Right.
I've also heard many times where fab operators say, you know what, I don't care if you're better than my human, just be as good as the best one and do it the same way day in, day out. That's all I ask. Like, just be consistent with the best.
Wow. That's it. I mean, if it was okay. So going into let's say connecting to the stack, as one would say, how do you integrate with historians, MES, EDA, tool chains, and handle time series events and contextual data at fab scale?
Okay, so it's a complex answer, but I'll try to be brief. Factories, fabs have extensive logging infrastructure, either on-prem or on the cloud, and a combination of the two. We connect to all of those existing data systems, and we retrieve that historical data, and then we use that to train. At deployment, we use the same type of systems to query the fab state at the given moment and then provide a response to that query, which is what's going to happen next or what should I do next, right? So we learn what systems that customer is using and we deploy on top of that, right? So again, going back to the point I made before, which is don't rip and replace anything that you're doing. We will deploy on top of whatever it is that you have. So we take the trouble to do all of that integration.
So one of the defaults is, of course, is, as you mentioned earlier, is the data. In terms of the integrity of the data or the quality of the data or the poor data hygiene, as you mentioned. What's your playbook for dealing with this type of data, where there's missing data, noisy sensors, tool-to-tool variation, and model drift over time?
Right. So part of what we built into Maestro is what we call an MLOps pipeline, which means we are constantly monitoring the model against a baseline to see how it's doing and decide whether we're going to fix it by deploying another model that's always being spun up in the background. So there's always a model waiting in the background to get deployed, and the trigger is executed through that MLOps pipeline that we built. So we're constantly monitoring and analyzing before the solution deployment and during the solution deployment. The better the more robust data set that you have, the more resilient it is to individual sensor failures or individual tools going down and so forth, because it would have seen that situation in the training data. And if it hasn't, we could augment that by providing simulations of those occurrences, right? And you can simulate 1,000 different what-if scenarios on each specific outcome and say, all right, out of these 1,000 situations, which is the best outcome? That's the one that you would take.
I see. With data, of course, comes security issues and IP problems. So how do you address, let's say, cloud security or tenant isolation and IP protection for hypersensitive data and semiconductor fabs?
Yeah. Again, when I say one of the barriers to adoption with customers is that they treat their factory data as the crown jewels of the company, right? They are very reluctant to give up any control over that. So we have different levels of security. One is we work directly with a customer tenant, meaning we bring our software to the data, not the other way around.
Okay. So you give it to them
So we give it to them, we deploy it inside of their system.
and you're like, you keep the data.
Yeah.
Okay.
You keep the data and you keep the models. The models are theirs. We don't own the models. Once we train a model on a specific customer data, it's theirs, right?
Yeah.
We don't take it anywhere else. So no data ever leaves the customer systems and comes over to our domain. It's always inside. The solutions could always be deployed on air-gapped systems. So we have that, and that ensures robustness and isolation at the deployment. And the data shared with minds.ai can be anonymized. We say to the customers, you can anonymize the data, you can mix up the labels. We don't care. We can train the model even though we don't necessarily know what the labels mean. We don't see labels like this is CVD or this is a photolithography or this is that. So customers can feel very comfortable having us train on their data because of that anonymization. And we ensure that again, the models remain under the custody of the customer at all time. So no data or no IP of the customer ever goes over to our side, and definitely none of that goes from one customer to the other.
So from your perspective, it's like, in an ideal world, if you could, I mean, at the end of the day, your solutions will only enhance itself and get better based on how much data it collects, right? At the end of the day. Would have you pondered, or could you ponder on getting these, certain fabs or certain current customers to team up together to share that data all together and create the mother of all AI scheduling platforms in the world?
I believe that at some point you could do that. You could create some basic standard models that could be used across multiple factories. Because at the end of the day, all semiconductor factories have similar tool sets. They all have etchers, they all have CMP tools, they all have photolithography tools. They may not have the same priorities or technology nodes or specific process technologies, but that is definitely a possibility. I just don't see it happening yet.
Okay.
I think they need to. We need a one generation of this technology to be deployed across multiple factories in order for that a tendency or reluctance to go away.
I see. With regards to operational. I'm trying to pronounce this right. Operationalization. What has to be true? People, process, tools for an AI solution to move from cool demo to a trusted control input on the line.
So we need close collaboration with the customer to show and explain the process, and that ensure that there's seamless integration.
Okay.
And that enables us to show the ROI. So that's what has to be true is that close collaboration.
Okay. And from that type of perspective, I'd be intrigued to actually understand is which KPIs do you codify in SLAs? Time to insight, model accuracy, false positive rate, yield lift. I mean, you mentioned it briefly in the rapid fire session, but how often do you review them with the customer?